say quadratics, which we know definitely what it looks like. It looks like this. And of course, the leading coefficient cannot be 0, or you wouldn't have a square. That's what makes it quadratic. That's where they look. Now, before I jump into this, you guys who are a little sad because I did not finish up 1.5, the word problems. Are you sad? Did I do one word problem with you guys on Monday? Oh, I haven't forgotten them. I just want to get this out of the way first. Part 2. Now, here's what it comes down to, which I think is going to be much better than, for right now, much better than transformations and piecewise functions, maybe. First one says on the handout, find the zeros of this function. And it's a quadratic. Now, did I say complete the square on this? Oh, are you kidding? I thought we were finished with completing the square. Can we have one other test to complete the square? And I'm saying complete the square. What other methods I could try? I could try to factor it, but they're saying no, complete the square. Or I could use quadratic formula. Well, let's complete the square for a reason. First, that leading coefficient. Let's go ahead and set this equal to 0. As we should know by now. That leading coefficient must be a 1. We all know that. To make it 1, divide by 2. And quickly turn it into this. Let's see if you guys will agree. Is that true? And since you had one of these on the first exam, let's isolate the x's. And we'll move that 3/2 over. Let's make sure everything's copied down correctly. Do not make a mistake here. And get ready to do this business, which we've done many times. So far, so good? Now, up to us to determine what is required on that blank. Anyone remember how to do that from that first exam? How do you find that number that's required on that blank? Because that's the critical number. We usually take what, 1/2 of this middle coefficient? You can't see it right quickly. So 1/2 of this, this will hold up for me. And guys, I think that much right there is what, -5/4? And then do what with it? Square it. That's just a little process to find to make sure you do not place the wrong number on that blank. I think it's 25/16. Let's hope. And here. Same process, isn't it? Let me get the right-hand side out of the way first. The right-hand side should be, if there's no mistake, should be a nice perfect square. What is it? What's the right-hand side, since we've already done this in class? Is it x subtract what number on the end? It's got to be 5/4. That's done. The other side requires me to do this business. With a common denominator of what, 16? Is that true, guys? So if I add them up with the common denominator of 16, I have to multiply this by 8, I guess. So I get -24 plus 25. 1? Is it 1/16? Yes or no?
Yes.
Okay. That was just arithmetic. And then what was the next step there to finally get to my answers? We do a square root, and thank goodness that 1/16 is nice and perfect. Plus and minus though to ensure I get 2 answers. Plus and minus what, 1/4? And the other side is this. Yes or no? To finally get what x is, easily done. My goodness, what you guys want to do? You want to move this over and write like this? 5/4 plus minus the 1/4, and I have the x on the other side there. Just get the x. Solve the equation. Let's hope there's no mistake. Now, can anyone tell me what these separate would give you? What answers am I looking at? They call them zeros now of a function. What are my zeros? I see 5 plus 1, that's 6. 6/4? 3 over 2, thank you. And the other one's 5, subtract 1, that's what, 4 over 4? 1? Done. And we did by completion of the square. We did this on an exam, didn't we? Oh my goodness, okay. Now, by the way, just out of curiosity, since I did go through this, and if these are the answers, if you get nice answers like this, more than likely, 100% of the time, the original function back there could have been factored. But they asked me to complete the square on it. Let me just do real quickly, with your help. If I had chosen factoring on the original guys, just for a little comparison, what do I need here? Do I need a -3 and a +1, or a -3 and a -1? Help me out. Are those the factors? Is that true?
Yes.
And if I split these up and solve these, I'm going to do it quickly, would you end up with 3/2 when you finally solve it, and 1, and would that agree with this? If you had done it by factoring. I see some looks like completion of the square. We just had it. Okay, so they asked us to do it by completion of the square. No problem. We got that done. We said, Professor, why are they taking us back? It's not right done. It's going to come up here shortly. Next, they're asking me to solve this one. X to the 4th, we call it g of x. Find the zeros. X to the 4th plus 4x squared, subtract 32. Please tell me, my students in my 4 o'clock session, did we do this one? Now, I held off, I redid it. We got some answers, so hold on, you guys who have not seen this. First, let me ask those, since we're now together as a class. The title of the worksheet is quadratics. Is this a quadratic? Nope. What is a quadratic? The highest exponent, called the degree, is what? 2. My highest exponent in this one's 4. Which means I will get 4 answers, but it's not a quadratic. So what they want us to do in chapter 2, that's why they brought this back in. They're saying, make it a quadratic. Make it take the form of a quadratic, and then you can either factor, use quadratic formula, or complete the square. Okay, I'm going to make it a quadratic, and we'll change its form into a quadratic. Now, did I have on the side there to let u be something?
Yes.
Yeah, this is a little technique in math. Let some variable, I chose a u, represent something in this, and then when I rewrite it, it becomes u squared. And therefore it's going to be a quadratic. Can anyone tell me what might I let u be in this one, and do a replacement, rewrite it, and it becomes a quadratic? Suppose I did this. I'll get you started with this one. Suppose I let u be x squared. It's usually that middle part. Now, if u is equal to x squared, please tell me, everyone in class, is x to the 4th the same as, from algebra, saying that? Is that still x to the 4th? And if I say let some variable u represent that, does this now become u squared? Now, is it a quadratic? The middle term, plus 4, and of course we'll substitute here also, u, subtract 32, set that equals 0, now you turn this into a quadratic. That's why they're saying go back to quadratics. You didn't see this in chapter 1. Now they're saying let that u represent something. Guys, by the way, if it's a quadratic, I'm going to factor this one. I'm certainly not going to complete the square on this one. I hope it factors. You guys who are good at factoring, help me out here. Is it u plus 8? And u subtract 4. Let me step back and look at it. You guys agree? Split this up. You got u to be equal to a -8. U is equal to 4. Am I finished? No, they said solve for x. I have u. So I've got to go back and see what u was representing to change this into a quadratic. U was representing x squared, so this really says x squared equals -8. squared is equal to 4. And then we're going to get into what my 4 o'clock session saw. Guys, this part is easy. This is x equals what? Plus or minus 2. Is that true? This part, you would probably say at one point in this class, Professor, if I do a square root to finish that thing up and try to take the square root of -8, is that possible? No. Now, what does chapter 2 do? It opens it up into another set of numbers to allow you to finish that thing up and not just stop and say no solution. And what they do, they establish what they call an imaginary unit or number. And I bet you guys have seen this. I is by definition square root -1. There's no way to get into a math 2 class that you have not seen this somewhere. You may not have been paying attention when you saw this being introduced, but it was introduced somewhere. I is equal to square root -1. Oh, by the way, just out of curiosity, before I get back and finish my problem up here, if I is equal to square root -1, which we will need later on, what might I squared be? Suppose you square that square root. You get -1. Just out of curiosity. Does anyone think they know what I cubed is? I times I times I. Well, okay, hang on. I heard I times I times I, right? This much right here is what? -1? Is that true? So is it -1i? Or just -i? How about I to the 4th? Just out of curiosity. This imaginary unit, which is a little strange. I to the 4th could be expressed as to find a value for it. I squared times I squared, that's one way to express it. That's I to the 4th. And each one of those I squareds is equivalent to a -1. So you're saying, Professor, I could write this as -1 times -1, which is what? 1. So I to the 4th is the same as what number? 1. I cubed, -I. I squared, -1. Of course, I, the square root, -1, the definition. Now, I know I haven't finished the problem up. I just thought I'd throw that out there. Does anyone recall what might happen if I ask you to find I to the 5th? And then I to the 6th? And I to the 7th? I'm just checking to see if you guys remember somewhere where you probably have seen this. Does anyone think they know what would come out if I ask you now to find I to the 5th? Guess what happens? We're not going to go through all this. We don't really need all of it. I to the 5th, it starts repeating. Gives you I. I to the 6th, -1. I to the 7th, -I. I to the 8th, 1. Was it -1 or 1? It was -1, wasn't it? Which one was it? I to the 4th? Oh, did I get I to the 4th? Oh, down here, 1. Is that true, guys? It repeats. Those 4 answers will repeat. So this one down here is 1, then all of a sudden I get to I to the 5th, I to the 6th, I to the 7th, I to the 8th, and so forth and so on, and it just repeats. And those 4. It's just out of curiosity. I need to finish this thing up. You guys were with me at 4 o'clock. Did we not go ahead and do, which looks so strange to do from chapter 1? Did we say, wait, Professor, I know it looks strange, but it's plus minus square root -8. And in chapter 1, you do what? You'd say, no solution. Stop. Can't do it, Professor. Now I can do it. One way to think of it is this. Plus minus square root -1 times square root 8. And why? Square root -1 can be identified with a what? I. So could I call this plus minus I square root 8? Now, can I do square root 8? It's not -8. Can I go ahead and do square root 8 as we usually do it? It's not perfect. So it's I plus minus I. And that square root 8 is 2 radical 2 if you break it down. I like it expressed like this. Plus minus 2i, different order, square root 2. those were the other two answers. So did I finally get 4? Yes, I did. They were not all real. Let me get the real ones out of the way first. -2, +2, those are good. Then those strange things. 2i radical 2, -2i radical 2. Let me step back and look at it, and we have the 4 answers. They call them zeros.
Sorry, Professor Ramsey.
Yes.
I have a question. For the I, can I put it like behind the equation?
No. I'm glad you brought that up. I tell students not to do that. You're saying, hang on, I know what you're thinking. You're saying, let me try to find it here. Whew. Like, give me the example. Like square root -8?
So for that one, I was thinking to put 2 and then square root 2 and then I.
You want the I down here?
Yeah.
Here's the problem. I probably wouldn't count it wrong, but I'll give you a warning. She wants to write that as plus minus 2 radical 2 and put the I down there. Which I can do. You absolutely can do it. What might you, if you write in that order, what might a student or someone think that answer means? Tell me.
It might mean that you're taking the 2 radical 2 and then you're putting another square root or -1 with that, so to be multiplied.
Gotcha, no problem there. Might they also think the I is with the 2? I know we wouldn't, but might someone think that I is with the 2 if I do it like that? Okay, 100%. If you keep it separate, make sure it's out there, not close to that square root. We're good. We're good. Absolutely. I'm glad you brought that up. We're good. Guys, anything else? So we got the 4 zeros. Now, I gotta check my time here. Oh my goodness, got 10 minutes. Number 3. I'll get this one out of the way. And then I think that this will pick us up to break here. Number 3, guys, chapter 2 says now find the zeros of this. I have h of x. And it looks like this. And I need some discussion on this. And sure enough, they're saying let u be something. Step back and look at it, make sure it's copied down correctly. Looks good. Now, suppose, since we're closing out this for the break, suppose they had not suggested doing something like this, and all you were staring at was that, and you're supposed to solve it. Tell me, without the process or the techniques that we're going to be using in chapter 2, what might you do as a good, clever, strong student to this if this were presented to you and they had not given you this? Just solve it. In other words, set this equal to 0. Can you tell me, well, beautiful problem to close down with. Tell me what you would do to try to solve it. Thank you. Might you want to square to get rid of that square root? Okay, of course we're going to use the techniques that we're trying to get us to do with chapter 2, but if you say, Professor, I suppose I did not know those techniques yet. Before I square it, to get rid of that square root, Billy, what might be wise for me to do before I do that? I just don't want to jump in and do this, because this would be madness. I don't want to do that. But I agree 100% we're going to square it to get rid of that square root. But I can't square it just like that. Any ideas what I might want to do?
Put 10 on the other side.
Tell me again.
Put 10 on the other side.
In other words, isolate the term that has the x in it, get that x all, square root of x. All by itself? Okay, hang on. What a beautiful problem. We got to do this. So I'm here, Professor, leave this term where it is. Move over the other two. Step back and make sure I got the signs right here. Move the other two terms over and have the term that has the square root in it isolated. Yes or no? Now can I square both sides? Much easier now to square both sides. Now if I square both sides, I think you're going to appreciate the benefit of chapter 2 here coming up shortly. Guys, I think this is 169, is it? Is 13 squared 169? And finally, if I square that square root of x, do I just get x? So it's 169x. Madness. Madness. Now you got to square this. By FOIL, some of you guys call it FOIL, or expand it out. Will I end up with 9x squared for the first term for sure? Anyone tell me what the middle term would be? It's madness. You're multiplying negative 3x plus 10 times negative 3x plus 10. Anyone tell me what that is? I got 9x squared for the first term. I guarantee you there's going to be 100 on the end.
I think it was negative 60.
I heard negative 60, and I agree with you. And then plus 10 squared, 100 for sure on the end. You guys agree? And by the way, is the square root gone?
Yes.
Okay, now let's try to solve this thing. Oh, by the way, is it a quadratic?
Yes.
Yeah, so I'm going to move that 169. This is madness. So you end up with 9x squared minus, oh my goodness, 169 plus 60. Somebody can help me out here. What will that add up to?
109.
Where are you going? It's a negative, a positive 169 move up. It's a negative 60 and a negative 169, isn't it?
Negative 229.
Negative 229 plus 100. Oh my goodness. I know it's almost time for a break. Ignacio. It's a quadratic.
Yeah.
I could stand here with your help and try my best. It might, who knows, it might factor. Because I really don't want to use quadratic formula on it. Can you imagine those big numbers already, you trying to take those into negative b plus minus square root b squared and all that business? That'd be madness. Does anyone think will this factor would really help me if it would? Because I do not want to complete the square. I do not want to use quadratic formula, not these crazy numbers. Does anyone think they know? Because I'm sure I've got some clever students who might see the factors. If it does factor. Does it? Mr. Park, Susan, help me out here. Will that crazy thing, if we have no mistake, will that crazy thing factor?
I'm not saying anything.
I know, I'd get so aggravated with that. Does it factor? I don't know myself. We could try 3x and 3x, or 9x and 1x. Those are the only choice. Oh, hang on.
Would it be 9x minus 4?
Hang on, 9x minus 4?
Yeah, then x minus 25.
Whoa, 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 if you have that, I so appreciate you. We can multiply that, guys. Of course, 9x squared I see. Now, if he's correct, this and this, 9 times 25, help me out, is that 225?
Yeah.
9 times 25, and then inside there's negative 4. So I got a negative 225 and a negative 4. Is that negative 229? Oh my goodness. It factors. I see some looks like a professor. I would never. If that had been on the test, I would see you during the summer. But I could not factor that. And of course, you split these up. You guys do it quickly. X is what? 4 ninths. And X is what? 25. Is that true? Yes or no? Okay. Now I say, Professor, before we take a break, please, could you show us a shortcut? By using what you were using over here, and then we'll take a break. Look at this madness. Would I ask you to factor something like that unless I was really, really, really in a bad mood? In fact, I think this my student did that for us. Now let's redo it and get the same answers. Much easier. Now, can anyone tell me? Be very careful. What might you let u be so I could have immediately rewritten this like I did this one and rewrite it in terms of u and got the answers much, much, much faster and easier. Who thinks they know what the u would have to be? Back here, the u was, where was it? X squared. Was it? Yeah. It's usually this middle. What's in the middle on this one? Square root of x. Now watch what happens. 3x, you said, Professor, you get crazy on me. Could I express 3x as this? Is that still saying 3x? 3 with radical x being squared. And of course I still have minus 13 minus 10 is equal to 0. Now, if I let u represent square root x, this becomes 3u squared. This becomes this. This becomes this. And we now change this crazy thing into a quadratic. Now, would you rather factor this quadratic or this one? If you had a choice. I would stay away from this one. This one's crazy. But we got it with the help of the student. This will now factor. I'm not going to use quadratic formula, even though you could. 3u, u. Guys, I think it's going to be a minus 5 plus 2. Let me step to the side. Is that true?
Yes.
Factors into that? Split this up. This implies when we solve it, we've done this before. This is negative 2/3. And this is a 5. Yes or no? Am I finished? No, they asked me to solve for x. This was in terms of x. So we have to go back and say, oh, this is square root x equals negative 2/3. And square root x equals what? 5. Now what would you do to find x? Before we take a break. What would you do now to finish this up? It says square root x equals negative 2/3. Anyone discuss anything about that? How on earth could a square root give you a negative answer? If I see you after this class, and you're in math 7, or math 8, or math 11, you walk across campus, and I see you, you see me, and I ask you, what is the square root of I think it would be the way to do this. The square root of 25. I would hope you would say, Professor, it's 5. Would you say plus or minus? If I ask you for square root 25 out on campus somewhere, this, are you going to say, Professor, there's only one answer? Or are you going to say, Professor, I enjoyed your class, and the answer is that. Which one is it? And you give me the wrong response, you're going to see me during the summer. It's only 5. If you see the square root notation, the square root symbol, they want only the positive. I don't know where in the past some instructors back somewhere have told students to accept, no, you cannot accept plus or minus 5. When can I accept plus or minus 5? If I ask you to solve this. Now is that plus or minus 5?
Yes.
No, but if you see the square root symbol, they want only the positive. So guys, this is impossible. This is ruled out. Makes no sense. You know, let this be a negative. This one though, square both sides. Fetch it up. Looks like x is what? 25. And therefore that means back here, he gave me a 25 when you factored, but I bet the other number that came out here, if I actually check it, take this 4/9 back up here, and be patient and plug it into the original, I bet it doesn't check. I bet it doesn't check. With me, guys? I'll check on my car. Sorry about that, guys. BMW in my car. Okay. Now, does it make sense? Absolutely. Guys, I love what you gave me for the factors. I'm not gonna check it because we're out of time here. I bet if you take 4/9 and your patient and you put it in here, I bet it does not check. And therefore, the only answer is, after all this work, is what? 25, was it? You know what, do this, guys. No, I'm not. Hang on, I know we're 5 minutes over. Bear with me. You go get your 10 minutes. Let me check. 4/9. Because the technique in chapter 2 says rule it out. It's not possible. Because if I square both sides, I would get 4/9. That's making no sense right here. So something's wrong. Here, it looks like 4/9 is going to come out, but I don't know whether it's going to check or not. Here goes. 3 times 4/9. Subtract 13 times square root 4/9. Subtract 10. Guys, what is, I'm doing a little canceling here. Is that 4/3? A little math here. And 13 times that square root 4/9 is what, 2/3? I think. Subtract 10. Just doing it quickly. So this is 4/3. Subtract, looks like 26/3. Subtract 10. Let me write that in terms of thirds. Let's write this 30 over 3. If I put all that together, do I get a 0? If I put all those numbers together, do I get a 0? Which I should. Do I get a 0? She head nodding, shaking yes. Do I get a 0 if I put those numbers together? 4 subtract 26, that's what, negative 22? Is it? And then negative 22 and a negative 30 over 3? Am I going to get 0? No, I'm supposed to get 0. So this number right here would not check that he gave me in terms of the factoring. That's why over here it was ruled out. I don't have the time. 25 will check. If you take 25 and you're patient and put it in, it will check. So 25 is the only answer. Wow. Enjoy your 10-minute break. Okay, so guys, enjoy.